So guys, you should receive your first practice exam today. Okay, not the ones that the access that I gave you on, I think it was on Thursday. Uh, the access I gave you, it's my exams, right? We're gonna take 12 exams, one each day, because um, believe it or not, our last class is next Friday, the Friday after the next. Okay. Okay, today we're gonna see Module 2, Section 5, AWS Core Services, Elastic Load Balancing.
Professor, I have a quick question.
Go ahead.
Do you know if Miami-Dade gives vouchers for this exam?
Yes.
For the certificate?
Yes.
How do we go about doing that?
I have to make arrangements for that. I'm not sure if I am going to schedule the exam or you guys will. I'm not sure.
Okay.
I have to check that.
So they may give us about like maybe 30 days to review for the exam, or less than that. Do you know?
You don't need that. I can tell you that if you've been studying and you've been following me and you take the exams that I'm giving you all that, you don't need 30 more days. That's too long.
Okay.
That's too long. That's crazy. You can take 30 days, but that's too long. You're wasting time that you can use for something else, for another certification or anything. It's up to you, at the end of the day, right? But I wouldn't wait that long.
Mm-hmm.
Take an easy exam. That's easy compared to all the stuff that you can do. So Module 2, Section 5, AWS Core Services, Elastic Load Balancing, Amazon CloudWatch, and auto scaling. All right. If we have time today, we're going to take an exam as a class. Okay. Together. I'm going to give someone else control of my screen, and then you guys will work together in the exam. Okay. Okay, so part 1, Elastic Load Balancing. Part 2, Amazon CloudWatch, auto scaling. Okay. So we're going to discuss the key concepts related to the Elastic Load Balancing ELB. So very commonly known as ELB. And Amazon CloudWatch and auto scaling. Auto scaling is the way some people call it is ASG, auto scaling group. Right? Very common that way too. So how to distribute traffic across Amazon Elastic Compute Cloud, EC2, instances using Elastic Load Balancing, ELB, the ability of auto scaling to launch and release servers in response to workload changes, and CloudWatch, how CloudWatch enables you to monitor AWS resources and applications in real time. Okay. Part 1. So basically, Elastic Load Balancer is a cup. It's a traffic cup. Yeah, what it does is like any cup is, what any cup, traffic cup does, if for some reason the traffic light is not operational, it's right there conducting the traffic, like distributing the traffic, and just telling people where they need to go, and just allowing people, stopping others, and allowing others to go. It's similar to a traffic cop, but it's not. Elastic Load Balancer doesn't stop traffic. What it does is distributes the traffic mostly evenly to different EC2 instances. Okay. So automatically distributes incoming application traffic across multiple targets. The targets are the EC2 instances, and also containers and Internet Protocol IP addresses. So you can also reroute the traffic based on IP addresses. Okay. Containers, ECS services. You don't have to know much about containers right now, but containers, you can create EC2 instances using containers, because you can run your EC2 instances in containers, which are isolated or self-contained, like containers. I don't know.
It's an S3 bucket. It's an S3 bucket, a container?
No. No,
It's
no.
not.
Container is something. It's a container where you can run applications on that. For S3, you don't run applications. You just what you can do with save data and also host a static website. But containers is something else. It's ECS. Maybe you can explore more on that. But containers is very popular because you can run applications like containers, and that way you are being more
Secure.
you can be more what's the word, independent. So one container is self-contained. It doesn't depend on other containers.
Got it.
So we have three types of elastic load balancers. We have we have the ALB, which is application load balancer. Okay. And we have network load balancer, NLB, and we have the classic load balancer, CLB. Okay, so you may not see, probably you don't see application load balancer, instead you see ALB. Okay, so remember the ALB is application load balancer. You may also see NLB, network load balancer, CLB, classic load balancer. It's easy to see where these guys operate, because when you see the application load balancer, then you can determine or identify this, and just remember that this guy operates on layer 7 of the OSI model. The OSI model, if you take a look at the OSI model, that's for networking. You have here that layer 7 is application, right? So it operates on this layer, okay? The application layer. That's why it's called application load balancer, okay? So it's flexible. It has a flexible application management, advanced load balancing of HTTP and HTTPS traffic. So whenever you see this, that the company needs a load balancer that has advanced HTTP and HTTPS, this is the application load balancer. Okay, so very important to know that. So this guy, as the name suggests, it works at the layer 4, which is the transport layer. Okay, the part that has a transport. Now you may say, why not the network layer if it is a network load balancer, where it operates on the transport? Because it uses TCP, right? TCP is transport protocol, right? That's why it uses the layer 4, right? So it has extreme performance and a static IP for your application. Load balancing of TCP traffic operates at the connection level. You don't need to know more than this for this exam. If you want to know more of this, then you have to go to the architect solution, or maybe a DevOps exam, or probably a networking specialty. But not for this exam. You only need to know that it operates on layer 4 and this one layer 7. Okay. Now this one is able to deal with millions of requests per second. So this is a super heavy duty load balancer. Okay. So if you, for any reason, you hear that your load balancer is designed to handle tens of millions of requests per second while maintaining high throughput at ultra low latency, this is the guy. Okay. This is the guy. Tens of millions of requests per second. Okay. And this is the, I would say probably the legacy one, the one that was the first one to be created. And the good thing about this one is that it can operate on both layers, 7 and 4. Okay. So it says existing application that was built within the Amazon EC2 Classic Network. When you hear Amazon EC2 Classic Network, what it means is the EC2s that were created outside of your VPC, okay? Because before, you could create your Amazon EC2 instances outside your VPC. Now you can't, but before you could. You were able to do that. So this is very useful when it comes to this type of EC2 instances outside of VPCs, right? It operates at both the request level and connection level. You can use them for EC2 instances inside your VPC, right? As well, because I've used them. Classic load balancer. Actually, the video that I posted on YouTube, it's an Amazon EC2 instance created in a VPC, and I use a classic load balancer. Okay, so basically the use cases here, this is for load balancing HTTP and HTTPS, right? Operates at layer 7. Okay, it's it's fast. It has flexible application management, but this one is even faster because this one is able to cope with 10 millions of requests per second, which is a lot of requests, right? If you think about it, in 1 second, okay, you can have 10 millions of requests. That's a lot of requests. Okay. So use cases here, access through a single point, right? One of the good things about Elastic Load Balancer is that you can access your application through a single point of entry. Okay, that's possibly the core concept behind an Elastic Load Balancer. Okay, I don't have to necessarily access my EC2 instances directly. I can go through an Elastic Load Balancer. Okay, so and by doing that, what I'm doing is decoupling my application, right? And this is something that we saw on Friday in the afternoon class. Okay, so that goes a little more in depth of that, but high level, what you need to know is that when you have a load balancer in between, you're decoupling your application, because I mean, if the Elastic Load Balancer breaks or something happens, the applications will not break, okay? And they don't depend on each other. But if you don't have Elastic Load Balancers, the applications will be communicated with each other. And then if one breaks, the others might break because there's an interdependency there. And that's not good for decoupling, in terms of decoupling. This is the guide for guaranteeing that your application is highly available. Okay, so remember that. Okay, it provides high availability and fault tolerance, like I just said. It works on that, right? And it increases elasticity and scalability. If you need to grow in size, Elastic Load Balancer can notify, auto scaling, and if you want to, increase the number of EC2 instances, the same thing. They're gonna be working together. Elastic Load Balancer, auto scaling, Route 53. All those guys are gonna be working together to guarantee high availability. Okay, you have to take that into account. So the classic load balancer use cases access servers through single point. That's possible with the 3 of them, right? Decouple the application environment. That's also possible with the 3 of them. Provide high availability and fault tolerance. That's possible with the 3 of them. And increase elasticity and scalability. That's possible with the 3 of them. But why do they say classic load balancer? If it can do the same things. Remember that classic load balancer is the classic one. It's the one that has to do with the previous generation one. And now Amazon decided to split this guy into 2, to be more specific, one for application and one for network, okay? But basically this guys is the 2 others, but it's just the previous way of, dealing with traffic, all that. So you can do multiple availability zones, but don't forget that if you want to have this, then you have to enable this. Okay.
Excuse me, Professor.
Yes.
You said that the classic load balancer was split into two, one for network and one for what?
For application.
Application.
Remember, we have an application load balancer and network load balancer. This
Got it.
guy
Okay.
was
Got it.
both of them before.
Got it. Okay.
If you want to have, if you want to be able to distribute traffic across availability zones, then you have to enable cross-zone balancing. Okay, this has to be enabled, right? Now you can have health checks. No, it's going to be sending some health checks to make sure that your EC2 instance is operational. If for any reason it detects that your EC2 instance is unhealthy, it will immediately stop sending traffic to that EC2 instances, and then continue sending traffic to the others. Right? It has a sticky session. It's a session that you can bind one user to a specific EC2 instance. Say that a user accesses your application through a mobile device, and then what you want is that user to be bound to the specific EC2 instances to have a faster communication, right? Only one, because you don't want that EC2 instance user to to be routed to another EC2 instance, so you can bind that user to a specific one, and then it's going to be communicated with that one only, right? But the downside of these sticky sessions is that you can limit scalability, right? Because it's that one only, only that one, right? You don't need to know much about sticky sessions. It's just for you to understand that it is possible to bind one user to a specific EC2 instance. That's why it's called sticky, okay? Application load balancer features: path and host-based routing. That's more advanced, but you need to know that you can route based on the path and the host, okay? That's something that is specific of the application load balancer. Okay, so when you see this words here, that's the application load balancer. And basically this exam, it's more of determining what things do, instead of just knowing what they do more than anything. I don't know if you understand what I'm saying. It's just determining what they do and not know what they do more, because this is all about concepts and theory, okay, more than anything.
Knowing what versus how?
Yes, how it happens. You don't need to know more about that for this exam. That will be for other certifications. But you have to know that the network load balancer doesn't work with path or host based. This is only for this guy. Okay, it has native IPv6 support, so inside of it, it supports this protocol, okay, this version of IPv6, which is rather new, right? Because last time I checked, they were running out of IPv4 IP addresses. So now there's this guy that has 128 bit. Remember we saw that an IP address has 32 bits, right? Like 4 RTETs. Each RTET has 8 bits, remember?
Yes.
Okay, so this guy's gonna have 128 bits. So it's gonna be much longer, right? Right now, IPv4 has 32, IPv6 has 128, right? And IPv4 is binary, zeros and ones. IPv6 is hexadecimal. It's gonna be a different notation, okay? You don't need to know much about that either. Dynamic ports, you can have, you can specify the port, like port 80, for example, right? So I want everything to come through port 80, but you can leave it blank and not put any ports, and then application load balancer has the capability of just receiving any port that comes in. Okay, that's why it has dynamic ports. Right. Additional supported request protocol. It has additional deletion protection and request tracking. Okay. Enhanced metrics and access logs. So just in case you want to see what is the information that, or of the resources that try to access your application, they will be logged in this access logs. Okay, so you have a lot of logging. You have logging in your VPC. You have logging in your Elastic Load Balancer. You have logging in your S3. You have logging in CloudWatch. You have logging in CloudTrail. So you have a lot of logging, you know, things that you can analyze at a very specific level, like here, or, you know, at a more general level, depending on whatever you want. And then it has targeted health checks. Okay, those are the targeted resources are the EC2 instances, right? Very important. Path and host based routing, native IPv6 support, dynamic ports, okay? Enhanced metrics and access logs, and targeted health checks. All right, mostly these three are the ones that make this application load balancer unique. Okay,
The first three?
The first three more than the others, right? So the first three, and probably this one, the fifth one. Okay, don't forget that. Very important. These are keywords that will help you determine what kind of elastic load balancer the exam is asking about. All right. Any questions?
No.
No questions? Okay. So here we have application load balancer use cases. So we have an application load balancer here. This is an image that I believe that you understand, right? So we have port 80, 80, 80. 80, 80 is basically the same as 80, but people use 80, 80. And 3306, if I'm not mistaken, this is Aurora MySQL. Okay, if I'm not mistaken. MySQL. Okay. MySQL. Okay. For database. Okay. So this is the port that you will open in a database RDS. So we have a listener here. Whenever you create an application load balancer, you have to create, or it is created with the application load balancer is a listener, is a rule that will listen through a port. Okay. So real quick here. So if I come here, I have a elastic load balancer here. Okay, listener, you see, here is listening through port 80, right? Using HTTP. Okay, so they have health checks. Okay, they'll be checking to this index.html, you know, just in case I have an HTML file. It's going to be checking on that. Timeout is 5 seconds. This is the timeout that it will be checking. This is the interval between health checks. Okay. So I have the instances here. I have two instances that are out of service because I think that I stopped the instances or terminated them. Okay. You see, there's no instances running. So for elastic load balancer, the two instances that were registered with it are out of service. They're not working right now. Okay. Availability zones. I have these guys. There's only one. The one that was working was in availability zone East 1D, and it was using the default VPC. Okay. It's a classic one. I created it. Classic. I chose classic. And this is the guy that we can use to access the EC2 instances. That's the DNS, right?
Mm-hmm.
An
Mm-hmm.
EC2 instance also has a DNS
Mm-hmm.
right here, but as it is stopped, there's nothing. But if I start it, there's gonna be a DNS and it's gonna be a public IP, okay? So we have the application load balancer, the listeners, and the targets EC2 instances that are inside a target group. A target group is something that we can create. Some here, right here. You can create a target group, right? In this case, I have one target group. It doesn't have any instance right now, but I can add. I think well, it doesn't have one because but I can register once, right? And
What's the purpose of the target group?
it's just let's say that you have 4 instances for development, 5 instances for production, and then you can have a target, and through the tags you can target specific EC2 instances. It's just to be more organized. Okay.
So basically, a target is like a tag to a specific instance.
Similar,
or...
yeah. It could be like a tag, but it's a group of instances, okay, that you want to have for specific accounts or specific departments.
A target or a target group is a group of instances.
The target is an instance. Is an instance.
Is an instance, and a target group is a group of instances.
That's right. That's right. You can have an elastic load balancer without a target group. In fact, if you take a look at my video, if you watch my video, you're gonna see that I didn't use any target group, right? A target group is just to be more organized, just in case, let's say that you have 2,000 EC2 instances. You have like 50 departments. You can target specific groups. Okay.
So in the case of the picture you're showing right now, how would you organize? Is this EC2 instance could be part of one target, or within the instance there are 3 applications? Can you target each one of them separately?
Yeah. Yes, you can do that. You can have it in one group or just individually.
However you want. That's your control.
In the video that I recorded, there's no target groups, and I target them individually. Okay, network load balancer use cases: sorting of volatile traffic patterns, single static IP address per availability zone, and ideal for applications that require extreme performance. So this is key word here: extreme performance. If you want to be, a heavy-duty application, the network load balancer is going to be very effective. And also, it has a static IP. Elastic load balancers, they have an IP as well. Okay? And it's static. It doesn't change. Okay. And also for sorting and volatile traffic patterns. All right. So load balancer monitoring, view hypertext transfer protocol, HTTP response. I think here, let me see. Monitoring here. See? So you have a lot of widgets here where you can monitor your application. For example, unhealthy hosts count, healthy host count, average latency milliseconds, request count, HTTP 500 counts, 500s, ELB 500 count, 400s, backend connection errors. search queue length, HTTP 200s, HTTP 300s. The 300s and 200s are response status code, okay? Whenever everything is okay, the response is gonna be 200, in the 200s range, when everything is okay. When there's a server error, the answer is gonna be in the 500s range. When there's an error on the client, in other words, the user, then the answer is gonna be in the 400 range, right? Whenever there's a redirection to any other thing, any other application or anything, then you're gonna have the 300s range. So the status codes give you information about the response, okay? What happened with the response, okay? Spillover count is whenever there's a lot of requests that are not processed because it's too much for the application or the elastic load balancer. So these are metrics that monitoring. Of course, you can see this in CloudWatch. If you click on this, then you can go to CloudWatch, which is the monitoring service for AWS. And then you can click here ELB, and then by service, probably per load state load balancer metrics. And then you can see here the last state load balancers. Maybe you want to see the healthy count, host count, then you can click here and it will tell you some data here, 1 hour, 3 hours, in a period of 12 hours, 1 day, 3 day, 1 week. Or you can customize it and see 1 minute, 6 days, whatever. So CloudWatch is the guy that will help you, monitor your application.
Professor, what did you say the 200 range was again?
That's okay. That's where everything is fine. It's gonna be the 200.
Everything's okay. Got it.
Yeah. Every single status code has a meaning. Okay.
Got it.
200s. So if you take a look at the 200s, for example, 200 is okay. Okay.
Okay.
200 is okay. 201 is created. When you create a user, for example, 202 is accepted. 203 is non-authoritative information. No, 204, no content. This doesn't necessarily mean that something is wrong. It's just there is no content.
Mm-hmm.
Right?
Mm-hmm.
Reset content, partial content, multi-service,
Mm-hmm.
This means that something is not wrong.
Mm-hmm.
Okay, everything is right, but you have to read the code to understand what was done. What's the option here?
Mm-hmm.
You see, client errors. When you're looking for a page, if you don't find it, you're gonna get this guy.
Yeah, we've all gotten that before.
Okay, if you want to access some resources that you're not
Yeah.
authorized, you're gonna get this guy.
Yep, seen that before too. Yeah.
So that's the way it is. You see the number performing SE. We saw that already. I show you in CloudWatch. Okay, load balancers automatically distribute incoming traffic load. ELB offers 3 types of load balancers: application, network, and classic. ELB offers several monitoring tools. Okay, monitoring tools out here. All right. Or you can simply create your elastic load balancer and see in the monitoring section here, and you can see the different metrics that CloudWatch evaluates for elastic load balancers. Okay. So CloudWatch, I think that by now you already know this guy. It's information to optimize your application. How do I know when I should launch more EC2 instances? This is the guy that will tell auto scaling. Is my application performance or availability being affected by a lack of sufficient capacity? Okay, and how much of my infrastructure is actually being used? Okay, so these are questions that you can sit down and discuss with, you can ask someone from a business owner. So because ultimately what you want to do is automate everything. Okay? So to leverage AWS in an efficient way, you need insight into your AWS resources, right? To have an idea of how healthy your resources are. So monitoring resource performance, we have, you know, this infrastructure here. We have an elastic load balancer. We have web servers into public subnets. We have 2 availability zones. We have an internet gateway, and then we have the internet, and everything is inside VPC, right? So what CloudWatch is going to be doing is going to be monitoring this guy here, right? The elastic load balancer. And at the same time, it's going to be monitoring your EC2 instances too, to be more specific, you know, at a specific level of your services. Okay, you can do it here, you know, to see how healthy your services are at this moment in time. Right. So Amazon CloudWatch, what is Amazon CloudWatch? It tracks resources and application performance. It collects and monitors logs files, and it gets notified when an alarm goes off. Actually, it doesn't get notified, it notifies people.
Notifies, yeah, I was wondering about that.
So what it says, what it's telling you here is you get notified
Mm-hmm.
when an alarm goes off. Using CNS topics, the alarm is part of CloudWatch. Okay, if you take a look at CloudWatch, you can create.
We did that, I think. Didn't we do that? Didn't we create? We did create alarms already.
No, we created a budget.
We did. Didn't we do alarms? Didn't we do alarms? I thought we did alarms. No.
If you did it, you did it in the lab, not with me.
In the lab. In the lab, yeah.
Yeah.
So alarms. So you can create different alarms here. You have different metrics. In my case, I have several alarms here. You know, you may see that insufficient data. It means that probably your EC2 instances are not running, or probably is in the process of pending or something. Probably nothing is happening because you know you don't have any data. You're not using your EC2 instances, right? But this is something that you know you're gonna have in the alarm. We have 3 states: alarm, insufficient, and okay. Okay, don't forget these 3 states, and services are gonna be in one of these states. Okay, in this case, these 4 guys are in the state of okay, and this one is in the state of insufficient data. So I deleted this application, that's why there's insufficient data. Okay, I created these tables. I think I created these tables in last class, during the last class, and then there's nothing, it's just okay. Okay. All right, so CloudWatch terms, it has metrics, alarm, and events. Okay, those are the terms of CloudWatch: metric, alarm, and events. I have metrics here, alarms, and events. By the way, I created an event here to stop an EC2 instance. I did it in the afternoon class. So you can watch that video, how to automatically stop EC2 instances every day at 4:18 p.m. Right? To automate that action. CloudWatch alarm examples, for example, Amazon EC2 instance, Amazon RDS, elastic load balancer. You can have different alarms. Let's say if the CPU utilization is greater than 60% for 5 minutes, just give me another EC2 instance. Okay, so that could be an alarm. The alarm will trigger auto scaling, and auto scaling will create 1 or 2 or 3 instances, whatever scaling policy you specified before. All right. If the number of simultaneous connections is more than 10 for 1 minute, I want you to scale out. Okay, because I have many people connected at the same time for 1 minute, in a row. That was straightforward. And lastly, the balancer, if the number of healthy hosts is less than 5 for 10 minutes, I want you to create another EC2 instance. I want to have 5, okay? If 2 are not healthy, create 2 more, All right, so this is gonna be, these are examples of alarms for, Amazon CloudWatch. All right, this is all specified by you guys. You have to create policies for this, okay, and alarms. Alarm CloudWatch, you can stop and terminate and reboot or recover an instance. You can scale another scaling group in or out. You can send messages to Amazon SNS topic, and then in turn, it will be sent to a subscriber. Okay. So these are actions that you can take when you have an alarm. Okay. I have done this in the past in the afternoon class. If you want to watch the video again, I'm telling you, you can see that one. This one we haven't done it, but we can infer that this is, you already know how auto scaling works, right? Can you hold for a moment, guys? One moment, please. Sorry, guys, I have to take care of something very important. So we continue. So review Amazon CloudWatch tracks and monitors the performance and health of your resources and applications. It enables you to track resource and application performance, collect and monitor log files, and you can get notified when an alarm goes off. CloudWatch consists of three primary components: metrics, alarms, and events. Okay, so don't forget this section here: tracks and monitor. Okay, don't confuse this with CloudTrail. CloudTrail is to track API call history. Okay, you don't monitor anything with CloudTrail. Okay, what you do is just record API calls. So whenever someone accesses the files, whenever someone deletes a file, whenever there's an interaction between one service and another service, So whatever happens inside your account, CloudTrail will record that. Record, okay? If you want monitoring, then CloudWatch is the guy, okay? So CloudWatch is gonna be all over the place, okay?
A quick question.
Go ahead.
Cloud, all those logs, all those monitoring, yeah, all those logs, can all those logs be exported or imported into Splunk and be searched through Splunk, or it just stays within the AWS?
Usually what people do is they just save them in S3.
Okay.
Okay. You can use, I think there's one service that works with Splunk. I think I remember it was for my DevOps certification. I think it's Fire. Let me see. Kinesis, Firehose. What's it? All right. Kinesis Firehose. Kinesis. No, Kinesis, you can send it to Amazon S3, Amazon Redshift, or Amazon Elasticsearch domain.
Okay.
One moment. Yeah, you see here?
Yes.
You see?
Mhm. Okay.
There was a particular service that helped you with that. So Splunk is a third-party service, right?
Yeah, it's a SIEM tool.
Yeah, and the AWS works with it.
Okay.
Yeah.
Thank you.
You're welcome. Okay, so what's scaling now? We have scaling, and Amazon EC2 instances and spot fleets. So whenever you see the word fleet, is a group of instances. It's very common to call a group of instances a fleet. Okay, you want to launch 20 instances. You can say, I want to launch a fleet of 20 instances. Okay. Scaling provides a simple, powerful, useful interface that lets you build scaling plans for resources, including these guys here, also Amazon DynamoDB tables. It has auto scaling as well. DynamoDB tables and indexes, Amazon Aurora replicas. You know, this guy has up to 15 copies of the database. So we have elastic load balancing here for every single auto scaling group. So we have the base configuration is 2, right? If you want to scale out, you're going to launch 1 instance here. And if you want to scale in, you have 2 instances, back to 2. I think that by now you already know this, because we've been talking about this all along the way since the very first day of class. Okay? By the way, auto scaling is free. What is not free is the resources that you create with it.
I have a question related to pricing with CloudWatch. Is that part of basic monitoring, or is it?
CloudWatch is free when it's basic. When it's detailed monitoring, then you have to pay for it.
Okay.
All right. Whatever we see here in my account is part of the basic one. All right. This is part of the basic one. If I want to enable, enhanced, then I will have to, do it manually, and there's some resources that when you create them, it gives you the choice to enable enhanced monitoring. I think that one of them is when you create an EC2 instance, when you get to the third page, it gives you the choice here to enable CloudWatch detailed monitoring. Okay, and it says additional charges apply.
Okay.
Okay, so maybe when you come here to the pricing section of CloudWatch, you're gonna see how much it cost. The first 10,000 metrics, 30 cents. You know, things like that. Okay. Amazon CloudWatch pricing is not heavy in this exam. I mean, they're not gonna. It's not one of the objectives of the exam. Not for CloudWatch. For the services, yes, but not CloudWatch. So auto scaling is free. Resources you launch, for example, instances based on specific conditions, then those are not free. Okay. Guys, something very important that happened to Oscar. If you created 6 instances during the challenge, you have to delete them immediately, because just in a matter of 3 or 4 days, Oscar already had consumed 85% of the 750 hours a month, because we created 6 instances. So can you multiply that by 24 and then by 3? That's going to be a lot of hours, over 700. So you will not be able to use your EC2 instances any longer if you go over the 750 hours. Well, actually you can, but you're going to be charged. Okay.
So
I have a
basically,
question.
net,
We
net,
have to do the same thing like with the labs, like when we create.
No. The labs is Amazon.
No.
It's AWS. That's not your account. It's their platform. You're using that in their platform. I'm talking about your personal account. If you are not aware of some services running, you have to go there immediately and just check what we've done in class and delete them immediately, because they're consuming time. One EC2 instance, one day is 24 hours. And then if it continues just for probably, let's say, 15, 20 days, you're going to be very close to, very close to 480 hours, CloudWatch will tell you, it will let you know, it will tell you that you're running out of hours, 3 hours. Okay.
as you when you reach 85%, by the way. So I'm gonna be begging you all guys, for some hours that you transfer to me.
I don't think that's possible.
No, I'm just kidding. I'm just kidding.
Just open a new account with another email.
That's right. That's something else that you can do, right?
Yeah.
You say again, you said you open a new account with a new email?
And you can close
Yeah.
that one. You can close that one.
Yeah, fair enough.
You can close that one. And I recommend, if you are forgetting about that account, I recommend deleting it, because probably you have some hidden services that you're not aware of. They're working there, and it's going to be accumulating, hours and hours and hours.
Yeah.
I created an EC2 instance and I forgot about it like a year later.
Yeah.
It was not running, but it was telling me you still have an EC2 instance. What? I mean, on our DS instance. What? How is that possible? And I have forgotten about that account. So that happens.
Lesson learned.
Yeah. Automatically register new EC2 instances with load balancers when specified, and you can launch across availability zones. Okay. So capacity management, day of the week, unused capacity, in this week here, this Wednesday, you're using the entire capacity, you're okay, right? But then when it comes to Friday, you're wasting resources. Okay, you have servers here that you're not using, right? So with auto scaling, I mean, let's imagine this is in on premises, right? And you don't have any, because you have a lot of capacity here. It's not being used, right? It's not being used. Don't use capacity. You're wasting resources, wasting money. But with an AWS with auto scaling, you know, your infrastructure will adjust. Your EC2 instances capacity will adjust to the demand that is happening now. You know, so you're saving tons of money here. I think by now you already know that. So typical traffic at Amazon.com, you know, it's like an electrocardiogram, right? So it's just, you know, it's pretty predictable every day, almost the same, right? Okay. So we have this pattern of traffic, provision capacity, you know, November, you have this, you know, provision capacity here, okay? And then you have this capacity here. But, you know, you don't have to worry about Amazon, Amazon.com. It's, you know, it's already covered. They're using AWS for sure. Same company, you know, same owner. One of my first questions when I started in AWS, I just asked myself if Amazon has to pay AWS for all the services. And because it's the same owner, right? But I think that for reasons of compliance and, you know, setting an example, I believe that, you know, I believe that Amazon AWS, AWS is billing Amazon.com for sure, right? Because, you know, they have to leave. I mean, you have to survive. Even if it is the same company, I believe that I would do that to set an example, you know, and also, you know, to comply.
Yeah, those are intercompany transactions. That is totally typical.
Yeah. So the challenge is to efficiently guess the unknown quantity of how much compute capacity you need. That's the challenge, right? So here we have you using 24%, and we are now using 76%. Okay. So that's the challenge. But as we saw the first day of class, we don't need to continue guessing anymore. We just stop guessing. Right? So first thing that you have to do when you create an auto scaling group, you have to launch configuration. A configuration is just the skeleton of the EC2 instances that you're going to be creating, which, by the way, are going to be exact, going to be identical one to the other, you know. So you're going to have the AMI in the launch configuration, and that's the question that you ask. What? You're going to have an instance type, a security group, a role. Okay, does this sound familiar to you? Does it look familiar? What do you create when you have to choose an AMI instance type security group?
EC2 instance.
Okay, so you're basically constructing an EC2 instance here. It's a configuration, which, by the way, is not going to create anything. It's just the skeleton. What is going to create that? Auto scaling. Okay, whenever the need arises, it's going to create EC2 instances based on this configuration. So for the auto scaling group, we need a VPC and subnet, a load balancer. Okay, this is optional. The load balancer is optional, right? It's not mandatory, but if you have it, it's going to be much better. Where? And then minimum instances. You have to have a minimum capacity, desired capacity, and maximum capacity, right? And you can schedule auto scaling. Okay, when it's on demand, scale out policy, scaling policy, So you can have all that when you create auto scaling group. I don't think I have any auto scaling group. I just deleted them. Okay, I don't want to have any. A launch configuration is the very first step. Okay, and based on this, you create an auto scaling group. So you see, first step, you have to choose an AMI, then a type, instance type. Okay, then you're gonna name it. You're gonna choose a role just in case this is gonna work with something else, another service. You can request spot instances and gives you the price per availability zone. It's the same region, different availability zones, same price for all the spot instances, right? Which is very cheap. Maximum price, monitoring, you can have, just like when you create an EC2 instance, you can have advanced details, and then here you can install an Apache server or whatever script you're gonna have, we wanna have here, okay? Only assign a public IP address to instances launched in the default VPC and subnet. Maybe you want to do it to every instance, or do not assign a public address to any instances. So if you do this, your instances are going to be created without a public IP. And when you don't have a public IP, what happens? You're not going to be able to connect to that EC2 instances through the web. Okay. And you're not going to be able to SSH into the instance either, because for that, as we showed, I think previously, you need an IP address for that to SSH.
What would be a use case for that?
For that what?
Do
Oh.
not assign a public IP address.
Just a private instance. When you don't have a public IP, that cannot be accessed by anybody. You can use the private IP to access it from private resources. But this one, no one from the internet can access this. Okay? Maybe you want to make it more private, that only resources inside that your VPC can access them using the private. You can SSH into your into your EC2 instance using the private IP, but that's going to be a different process. Okay. But the most common way is using the public IP, is the easiest one. You don't have that, then you don't run that risk.
So it is possible to SSH to a private?
Yes, using the private IP, but it's a different process. Right? So continue here. Dynamic auto scaling, elastic load balancing, auto scaling, CloudWatch. This is dynamic. You don't have to do anything manual. First, you have to configure it, right? But then after that, it's going to be automatic. So ensure that your architecture can handle changes in demand. A key advantage of a cloud-based infrastructure is how quickly you can respond to changes in resources needs. So here we have auto scaling, users, accessing the EC2 instances, there's no interruption because auto scaling will be alerted and scale out, right? I'm very confident, guys, that you already understand whatever this is showing, okay? Because I think that we have spoken so much about this that at this moment, it is super easy to understand. Okay. So the lab for today, I want to show you in Pocarium. Okay, so right now it's 10:36. We're gonna take a break and be back at 10:46. Yes, go ahead. Yes.
Yeah, quickly, sorry to interrupt you. In terms of lab, I don't know if you could see, the message that I sent you via.
I responded and I said that today after 4 p.m. when I finish my afternoon class, I'm gonna check on that and get back to you with an answer.
Okay. Thank you very much. I didn't see your response. Sorry.
I will check the lab. If this is something that I cannot fix, then I will have to contact those people. They are the ones that can fix that are the developers, the one that created the lab.
Do the rest of the guys, do they did it, without any problem?
Which lab?
I only heard a complaint from Martina.
I had the same issue you had, exactly the same issue.
But I don't know if the other guys they did it and
I finished easy, no problem.
Then if someone didn't have a problem, then probably you failed a step. Probably you skipped a step or something.
I've been able to do the labs with no problem, even the last one.
So I recommend.
I was able to go through all of them.
Okay, I recommend starting from zero again and be, careful, step by
Now,
step.
something that I found out is the menus have changed.
Yeah.
Yes.
The pull downs and the description also have changed. So
yeah, they have changed a little bit.
The other one.
Yeah, I agree with Maria. They have changed a little bit. You just have to don't go like automatically. Don't follow the instructions just to follow the instructions. Make sure you read and kind of like figure out what you're really doing.
Yeah, no, that's what I try to do, and I reviewed it like thoroughly. But anyway, yeah, probably I did something wrong. I never know. But it was weird because it was the very last step, the one that didn't work. So
Me too.
Huh.
Yeah, me too. And also the other thing that I noticed was that when it came to creating the subnets, the instructions had, create the first subnet and then create the second subnet. And I wasn't able to do that. I was able to do the two subnets together on the same page. It wasn't one first followed by the second one.
Related to labs, can we repeat the labs? Is it possible to do once you finish it?
Yeah.
As many times as you want. As many times as you want.
Yeah.
I'm going to do what you suggested, Professor, which is do it in my own personal account.
Okay, but don't forget to delete the resources when you finish.
Yeah.
Okay, guys, I'll see you here at 10:48.
Okay.
okay.